Good afternoon, everyone. Thank you very much for being here. I sincerely appreciate it. My name is Deji Akamalafe. I'm the practice lead for Microsoft Application Virtualization on vSphere. And right in the back there is my customer. Thank you for being here. I'll hand over to you.
Okay. All right. I'm Adam Ball, Principal Systems Architect for Strategic Products and Services, and I'm here also with Deji here to talk to you guys about virtualizing Skype for Business on vSphere. So, how many times have you guys seen this slide yet? Like 27? Oops. Oh, there we go. So real quickly, what we're going to do is we're going to kick in and talk about what is Skype for Business. Just quick show of hands. How many of you guys have deployed Skype for Business within your organization? All right, we got most of you guys. So we'll whip through most of this really fast, and then we'll kick into some of the better technical stuff. So really quickly, what is the promise of Skype for Business? Is this, and I always call it the promise based on the idea of one client to rule them all, right? So we've got the ability to do instant messaging and presence, we've got conferencing, we've got using it as your PBX. Everything is all within one client, so your coworkers, your customer, whomever that is, doesn't have to have a phone on their desk, doesn't have to have something else to do meetings, all of those kinds of things. Skype for Business is based on real-time communications, and it's really important for us to think about this just based on the fact that it is live, right? I mean, we need to have certain things in place here so that people don't hear issues, because when we're talking to each other, we take a lot of verbal cues or visual cues when we're sitting there face-to-face with folks. So it's really important that we understand why real-time is important with all of this. Because what is the worst that can happen? We can end up with things like, I always refer to it like the max headroom, where you kind of get that choppy audio, you get people talking over each other. This will happen a lot of times with latency. And then we also get like feedback, like I'm kind of ending up here that he's helping me out with, probably because I talk too loud. But all of these things combine to provide a really poor user experience. And at the end of the day, when you deploy Skype for Business or any other UC product that involves voice and video, and a user has a bad experience, the very first thing they're going to say is this is junk, and try to pitch it. So battling that perception can be a really big issue. We have a lot of cause and effect that happens here with the different components here. So latency, when we have latency over 250 milliseconds, so i.e. if you're from Australia and you're trying to talk to somebody in the US and you have a really long latency, did I get that better for you? All right. Long latency network path, you get talkover. So that's actually one of those things that we see frequently, where people will be trying to talk to each other and then they'll talk over each other, and it's just based on the latency. The other thing is with network, with jitter, network bandwidth and distance can play an effect in that. For those who don't know what jitter is basically when the packets are arriving at different rates. So if you've got a bunch of packets arriving really perfectly, where they're all arriving a millisecond apart, then you basically have zero jitter. But what happens is when that comes back and forth, and you might have one packet coming in, a bunch of packets coming in at like 1 millisecond, and then you have this bigger delay. What you end up happening is the jitter buffer will fill up, and then it'll dump, and then you get somebody who sounds like the Chipmunks. Anybody experienced the Chipmunks effect in Skype for Business? Yeah, all right. And that's always one of those things where people go, what's happening there? And that's usually due to jitter on the network. And then lastly, and what we're hopefully going to address here for you guys today, is along the lines of insufficient resources. And when you get those insufficient resources, what happens? And what can we do about it? So performance considerations. So I've been involved with what became Skype for Business since late 2007. So back when OCS came out, for those of us who have been around. And that was a physical only deployment. And I remember the company I was working with, we started deploying it on VMware a long time ago. And as we kind of moved forward, every time I would look at what Microsoft made the recommendations, I'd think, oh my gosh, that's a lot of resources, right? Especially back in the 2007 to 2010 time frame. Nowadays, we just look at this and go, yeah, here's some more cores, here's more memory, right? But back then we couldn't. But even still today, when we talk about dedicating 12 cores towards the application or 32 gigs of memory, that can still be pretty intense for a lot of organizations, or unless you're really big and just happen to have a lot of iron around. Disk is also really, really important here when we talk about IOPS. They say or similar performance because, quite honestly, most of the people that we deal with or that I work with have either direct hard drives on their systems, coming off SAN, or maybe using flash, right? And it's important to make sure you know how many IOPS you have, because Skype for Business can really be impacted by disk write performance. And then lastly is your network. Oh, don't get too close to me, Deji. The network is important here. And when you're talking about within your VMware environment, we'll talk more about how to configure that. But even at the Windows layer, and understanding that you need to have at least a gig throughput for all of that is going to be important. This is just what we're talking about for front ends. Edge servers have a little less requirement, but still similar. There is a link to the deck. I do tell people that they need to make sure that their resources are appropriately taken care of here from a virtual perspective. So availability considerations when we think about Skype for Business. And we have a bunch, right? We've got within the application, just native high availability happens, right? We can do a pool where we've got multiple front end servers or multiple servers that are being load balanced across. And in that way, so for example, if we have a server fall down, maybe you need to take it out of for maintenance, something of that nature, we still have high availability. Now here's the big deal. High availability and DR are two totally different things within Skype for Business, and that's important to know. With high availability, you take down that server, everything still stays working. IMs stay up, users are not impacted for the most part, unless they happen to be on that server that falls down right when it falls down, right? So if you had a server that died for some reason, those users would get automatically, you'd see a sign out, sign in experience, but then they'd be back up and running. The other thing that we have to worry about from native high availability is we've got our SQL backend, so we can use mirroring or always on by default. And this is important for being able to maintain that. The next piece though is the disaster recovery. So it's not just a single server, but we also have the capabilities to do pool pairing, which gives us a full redundant backup, right? So we lose a pool, we move over to pool B. The important part to note about that though is that is a manual process to do that failover, and during that time your users might stay signed in, but then they'll get that limited mode. And then the next thing that as we go forward, we'll talk about is how we build into that the redundancy within vSphere and within VMware. All right, so I want to tell a story really quickly here about avoiding the trap. Heard this story a number of years ago. It was actually told originally by Alan Percy. It's called Avoiding the Pilot Trap. How many people here start out with their applications by saying, hey, I'll deploy a really quick small server and we'll test it, we'll get it up and running, and you might test it with 5 people. How many people have done that, right? You get it all going and you're like, oh, that's awesome. And then the boss comes in and says, hey, this is working really well in our team. Can we add so-and-so? And then you add so-and-so and you keep adding people to it, right? And you kind of started off, right? And you took a look at those performance, the performance amount of resources that you needed to give it, and you said, I'm only giving this for 5 or 10 people. I'm not going to give it all that. I don't have 12 cores and 32 gigs. I'm not giving that much for 10 people, right? And so you start doing this, right? Then all of a sudden you've taken this project that was just a pilot, a proof of concept, and now you've got 50, 100 people on it, and now you got the bigger bosses coming in, right? And you start saying, hey, I need my C-levels on here. Is that really the smartest idea to be doing with a pilot? Probably not, but now you've built this into a business critical app, right? And now you're stuck. Where do we go from here? Because now people are starting to come and they're saying, hey, this Skype for Business piece, it's just not working for me. I'm getting, robot voices, I'm getting chipmunks, I'm getting dropped calls, I'm getting all of these things. And you're like, but it was a POC. Well, not anymore. So as we go forward here, and I'll let Deji take over for a little bit, we're going to talk through how to be better about that.
By show of hand, anybody in here virtualizing their Skype for Business today? On vSphere? On something else? By show of hand, how many of you who will virtualize is happy with the experience? All right, a few of you. Okay. So, all right. One of the objectives, one of the takeaways from these sessions today is that you will understand some of the things that make your Skype virtualization experience horrible. So we're going to go through a series of what to do, what not to do, what to avoid, how to optimally configure your vSphere infrastructure to give you the best experience you can get out of Skype for Business. If there's anyone in this room who still believes that Skype for Business is not a virtualization candidate, we aim to disabuse you of that mindset today. Hopefully, this deck is not necessary. Can we all agree that it's all supported? Virtualizing Skype for Business is fully supported without any caveat from Microsoft or from anyone. However, if you were to virtualize your Skype for Business and you were to run into a situation where you don't get support from any vendor, you are covered. We have multiple layers of coverage for you, providing you assurance that virtualizing your Skype for Business application and infrastructure is not a gamble. And you won't be left alone or left holding the bag. If any of these all of these combined do not provide the confidence you need, you can always count on the TSA Net Alliance, which is an alliance of major vendors all over the world, IBM, Microsoft, VMware, where we come together and we say, if my customer does X, Y, and Z with my application or my solution, and they have a problem, and I think it's your problem, and I cannot help them, I can take the case and work directly with you to provide a resolution for the customer. So if you were to get into a place where your Skype for Business infrastructure has any issue and you getting turned away by any vendor, you come to us, we'll take that case from you and we'll work with the vendor. Assurance, confidence. All right, now, why would you virtualize Skype for Business on vSphere? Apart from the fact that it is certified, and it's unaware. Your Skype for Business applications, the components should not know that they run on physical servers or on virtual servers. And if they do, we have done something that we shouldn't be doing, and we'll try to point those out to you here today. You virtualize them because, as my colleague just mentioned, what's the biggest requirement? 12 cores, 32 gig of RAM. You can buy a single server today that has just those resources. You will most likely get a 2x10 hardware, maybe 356 gig of RAM, and because you want isolation and you want redundancy, you're not going to put all your Skype for Business front end, back end, whatever, into the same server. So you will most likely have multiples of them, and you will most likely be using those 20 cores or 40 cores at a fraction of what they are. 12 cores, 32 gig of RAM. That's what virtualization buys you. We can now take one hardware and have multiple instances of those component servers, and layered with the native high availability features in vSphere, you can have the same redundancy that you're expecting. We clear on that? All right. Can I use vMotion and DRS when I'm virtualizing my Skype for Business application component? It's a question. Yes or no? I see you shaking your head. Thank you very much. I've been looking for you. All right. Why would you not? Exactly. Exactly. So the fear of using vMotion, DRS, and all the native capabilities of vSphere with Skype for Business application is that when we do that, we may lose connectivity, we may lose sessions, we may have jitter, we may have all these problems. My customer is right there in the back, and I will show you a demo or a video of a situation where we actually do live migration, live vMotion of ongoing calls and without packet drops. Okay, what's the impact? It is possible when you do vMotion based on how we do vMotion. Let me explain that briefly. When you ask us to teleport a VM from one host to another host, we don't do it magically. What we do is we copy the state and the memory of that VM over a period of time. We come back and get some more as it's running without interrupting any operation on that VM. And at a last minute, we come back and get some more, whatever is left of that VM. And then we quiet that VM and say, okay, we're going to freeze you and then switch you over here. We do context switching after that. During the freeze period, what do we use for freezing this VM? It's Windows VSS. Okay. What do we use? We use that technology and we freeze the VM and we bring it up here. That brief period of freezing may interrupt that session and that session alone. Okay, you may have multiple sessions ongoing at that time, and this is why we recommend the efficiency and the superior capability of vMotion and DRS and all these vSphere HA is beneficial. However, because your call and all these sessions you have are also very important to your end users, we recommend that you use DRS, vMotion, however, with administrative intelligence. Don't do vMotion during your normal business hours. There may be a situation where you have an emergency and you need to move a VM. That is out of band maintenance. And at that time, you would have set the expectation appropriately that, okay, there may be some brief interrupt. When you set up your Skype for Business workload in the vSphere cluster, we ask that you use anti-affinity rules to separate the component servers, the likes. Like your front-end servers, if they are going to reside inside vSphere infrastructure, we ask that you set anti-affinity rules so that when a host is impacted, not all of your front-end server or like component servers are impacted. Make sense? All right.
We're going to give a quick demo here.
And by the way, my customer is a
So
yeah, we dog food our own thing.
So we're going to give a quick demo, and let's just go ahead and get a pause.
Escape. Escape it.
Yeah, we'll just quickly. And real quickly, I wanted to make a comment on this just with before we kick this off, and you'll see this here, that Deji, and just re-emphasize something that Deji said of when you're thinking about vMotion, right, this is not what you do. You're not going to be looking to just kind of whimsically do this during like your busiest hour Monday morning at 9 a.m., right? Like I cannot emphasize more about what Deji said about the fact that this is something that we have to use our administrative intelligence with it. And you'll see here as we go through this why that may be, so.
Okay, here we are. We're going to do a quick demo of a conference call running while we do a vMotion test just to exemplify the call quality and how things can stay up during a vMotion and what that reaction would be and what the users would experience if they're on a conference call while a server gets vMotioned from one host to another. You can see that we're in a conference. We've got 4 of us here. We've got 3 people joined via the Skype for Business client and 1 more person in on the phone. We've got video going. We've got a desktop share happening as well. So we can kind of just see all these different results across the board. The first thing that we need to do is that we need to go find out which host or which front-end server our conference is actually running. Since this is a demo environment, we only have one conference total running on all of our servers. So what we can do is we can come in here and look. I've run git cs Windows service to be able to find it, and I was able to find it that it was on FE1, and I can see that here through the RTC AVMCU. This is where our audio and video is going through. That I can see my conference and I can see my number of users equals 4. And because of that, that's where our audio and video is happening at this point in time. So now that I know where our server, our virtual machine is, I can actually go and look to see what host that's on over in the vSphere web client here. And I can go look at FE1, and I can see that here, and I can see that it's running on ESX1. What we're going to do is set up a couple of tests here as we go through this, and we're going to do some continuous pings just so that we can see how things react as we're doing our migration. Then we'll come back over here and do our migrate. The first thing that we're going to do is we're going to start from our server. We're going to start a ping that will just ping our gateway over here. And then from our guest machine, which is on a separate network, we're going to go ahead and start a ping to the server and just watch how things happen here as we do our migration. Back up our web client here, and we're going to go ahead and start our vSphere vMotion here. We're going to go down to migrate. In this case, we're just changing the compute resource only. We're going to choose one of our hosts. We'll just choose host 2 over here. We'll validate that everything is compatible and checks out. We're going to leave everything else here the same. We're going to leave it on the same network. We're not doing any other changes within this. And we're going to go ahead and schedule the vMotion with high priority, which is recommended. We're going to come in here and go ahead and complete that. So during this time, what we're going to do is just be able to watch this. Deji and Hemel, you can guys kind of chime in of what you're seeing from your side and get some good quality in here.
Yeah, so can I go ahead and launch up the client here? And so just want to make sure, how the quality would look like exactly for the last second when the stun operation happens during the vMotion process.
Yeah, can you go ahead and bring?
So like you guys can see, it looks like the vSphere must have just migrated and completed. Yep, and we are back.
There's our robot voice, right?
And is anybody talking? Hello?
Yes.
Now we just came back. So
Michael's on the line.
Yep. So I got a little bit of silence, and then I got a little bit of the voice speed up. Deji, it sounded like you were the Micro Machines guy talking for a few seconds as the vMotion completed during that stun process. So, and you can actually see in up here in Hemel's screen that we've got the red bars up, and now it just changed over to yellow, and then we're going to go back to white here as everything smooths out. And biggest thing here that we want to notice is that call quality can be affected during that stun period, and so, but the vMotion succeeded successfully. And now we're back to the white bars. And Hemel, if you'll actually just jump back to the, real quickly to our server, and we'll just do another git cs Windows service, and we'll just show that the service is actually, the AVMCU is still running here on our, and so we can still see that our AVMCU still has the conference. It didn't move over to another server or anything else like that, and so we're in good shape.
Right, and I just want to add one more point here, that since we were doing a continuous ping here, there was a 1 second timeout, which is expected during the last stun process that happens when the vMotion happens.
I'm going to just stop that there. We'll bring up our presentation here. And I think what we've got is, we actually have one more example real quickly from recently that that happened just actually this past weekend within VMware. They actually had to bring over onto new hardware. They needed to do some shifting around of virtual machines, and they were able to move the entire pool, obviously machine by machine, over to new hardware using vMotion, and they were able to do that, including the conference call that they were using as the status call for that product, for that move. And I know that Richard, you're back there, and your team did a fantastic job with that. And just everything I heard came back after it was like, hey, this all worked. We didn't really have any interruptions to the end users, right? To your coworkers, which at the end of the day is the biggest, most important thing as we deploy systems. So,
okay, how did that happen? 2 seconds, 1 second, ping, drop, and the VM is on a different host. Not by magic. Please, these are the things that will make your virtualization experience horrible and terrible. And these are the things that will make it impossible for you to vMotion your Skype for Business workload successfully if you were to do it during business hours. Virtualization is not the same as physical. We pull resources, we abstract these resources, and we share the resources. Because we share all these resources, we want all VMs in the vSphere environment, in the vSphere cluster, to use their resources judiciously. If you were to over-provision or over-allocate resources to your VMs, that can be counterproductive because of penalties, because of co-scheduling, because of other things that we watch for at the hypervisor layer. More is not always better. And there are more potential chokeholds when you are virtualizing that don't always exist or normally exist in the physical world. Number one, your hardware must be on the VMware's hardware compatibility list. Always disable unused resources. Memory scrubbing, we've been advertising and advising for this for a very long time. Leave memory scrubbing rate at the BIOS default. You do not need to change it for anything. Your power scheme should be high performance or equivalent, whatever it's called in BIOS. Enable turbo mode and disable processor C states. There are some hardware specs where you can buy specific number of cores and then limit how many of those cores get used. Please do not do that. Okay, it hurts your workload, and we recommend that you do not disable cores at the physical layer. Right size the hardware if you are not going to need that many cores. Buy the right size number of cores. I cannot tell you how many times we've had escalations where we've troubleshot many Skype for Business implementations, only to find out at the end of the day that wrong BIOS, wrong firmware, and wrong drivers at the physical layer were the cause of those problems. We spent many hours, many days, weeks at the Windows, at the Skype for Business layer, at the hypervisor layer, and then somebody gets the idea, why don't we just check the drivers of those physical hardware? At the ESX level, we also recommend high performance. We recommend that you enable hyperthreading. If you think, or if you've read somewhere that hyperthreading hurts Skype for Business somehow, it doesn't. And that's some guidance from some other applications being extrapolated and applied to Skype for Business. There is no technical or technological reason for you to disable hyperthreading for Skype for Business. Resource overcommitment is one we advise against. When we were doing the vMotion, I told you how vMotion works. We copy the VM, incrementally we move it over to another host. If there are no resources in the ESS cluster, in the vSphere cluster, we won't have enough resources to shift the load temporarily. So if you are overcommitting, definitely your sessions will disconnect if you try to do vMotion or DRS or even vSphere HA. Okay? It increases your vMotion operation. And it will definitely lead to poor performance because, again, we virtualize, we abstract hardware. We do not produce or manufacture hardware. If the cores are not there, if the memory is not there, there is nothing for the hypervisor to give to your VM. We'll be swapping, we'll be ballooning, we'll be exposing serious defect to your Skype for Business workload. Should we enable NUMA or should we disable NUMA? There is no negative side effect to leaving NUMA enabled for Skype for Business infrastructure. If you have a dedicated vSphere cluster for just Skype for Business alone and you feel like disabling NUMA, go ahead and do it, because the NUMA application itself is, the Skype for Business application itself is not NUMA aware. However, don't forget, behind every Skype for Business infrastructure is a SQL server, or one or more SQL servers. SQL servers know how to use NUMA. They are very efficient. SQL Server is very efficient when it's able to see virtual NUMA. If you are co-locating your SQL servers and your Skype for Business server on the same ESX cluster, then please do leave virtual NUMA, vNUMA, and NUMA at the physical hardware enabled. Does that make sense? All right. Yeah.
One of the things that Deji just mentioned was SQL. Every front end for Skype for Business has SQL Express on it. And SQL Express, it's good to know that SQL Express will use the maximum of one core or one socket or 4 cores, whichever comes first. So the big important piece, and this actually ties into vSphere 6.5, is the fact that you can have, when you deploy your CPUs and cores to take advantage of vNUMA, you can do that now with 6.5 and not limit yourself on the SQL Express side, because on previous versions, it was 1-to-1, so you had to have one socket, one core, and if you did that for vNUMA, you could actually be hindering your SQL Express install there, but with 6.5, that's no longer there.
If you have a large vSphere infrastructure or cluster, and you are co-locating your Skype for Business component servers with other workloads, and you want to be able to guarantee resources to those Skype for Business servers, in the event of resource contention within the vSphere cluster, we always recommend that you set reservation for the memory, at least the memory that you've allocated to the Skype for Business component servers. If you set reservation for the memory, that VM or those VM will always be entitled to that amount of memory, even if you get into a stress situation within a vSphere cluster. Does that make sense? All right. We are going to jump into IO queuing, and IO queue happens at multiple levels, especially at the disk and the network level. When you create a VM on vSphere, we give you one type of SCSI controller by default. It's called LSI Logic SAS. LSI Logic SAS has a default queue depth of 32, and I'm sorry, there's no slide for that. As a queue depth of 32, you cannot configure, you cannot change that. We recommend using a VMware Paravirtualized SCSI controller, PV-SCSI, for your Skype for Business workload. Why? Because they have larger queue depth. By default, out of the box is 64 queue depth. You can configure, you can increase that to 254 per device and 1024 per controller. Now, 32 against 64, that's twice the I/O throughput. Your queue depth is substantially larger, and we can get more disk I/O through without bottlenecking your Skype for Business VMs. When you use PV-SCSI, please bear in mind that the drivers for PV-SCSI is not native to Windows, and that's why we give you LSI Logic SAS by default. You have to inject the drivers for PV-SCSI into Windows before Windows can start using it. And how do you inject that? It's through the VMware tools. The VMware tools gets into the OS, and the OS is now able to see PV-SCSI and be able to use it. Now, because Windows defaults to the LSI Logic SAS, we recommend that you take the extra steps and add this registry key to your VMs when you are using PV-SCSI. This is what tells Windows that now we have larger ring buffer and you can send more I/O through this SCSI controller. Let's do a quick illustration of what I just went through. This is your checkout counter, and as your IOs, your customers are arriving, because there's only one person servicing the request, they're getting backed up. This is your IO queuing right here. Our objective when we send IOs from a VM or from an application to the storage is for us to reduce the amount of time spent in the response in this queue here. The queue time and the service time. We want to minimize the trip from the application, the VM, through the hypervisor to the storage and back to the VM. Now, if you build your VM and your VM gets one SCSI controller, and you have many disks, many VMDKs or RDM or whatever you use attached to that single SCSI controller, this is what is going to happen. You're going to queue IO. We recommend that instead of doing that, why don't you add more SCSI controllers? A VM can have up to 4 SCSI controllers, and by opening up the lane, by adding more controllers, your IOs now have multiple paths to travel through. Okay, so this is a quick illustration of that. 4 SCSI controllers, and there are no queues. Any question on this? Talking about queues. You may read on the internet that when you create VMs or Skype for Business or any workload on vSphere, do not use a VMX.NET 3. I'm telling you that the opposite is the case. Do not use anything for Skype for Business workloads that is different from VMX.NET 3. VMX.NET 3 is the greatest and the latest drivers, network card that we have on vSphere. It is the only one that we're actually optimizing, and it happens to be the only network card on the vSphere platform that supports Windows receive size scaling. How is Windows receive size scaling important to you? RSS is what enables Windows to leverage multiple CPUs for network packets. So when your Skype for Business is busy and you have all this session, you have all these videos going on, you have everything operating and people are joining and it's busy, there is a lot of network packets getting transferred. If you don't have RSS enabled in Windows, only one CPU will be servicing those network I/O requests. Eventually, that single core will die. Before it dies, it will be dropping packets. And you will be telling your vSphere admin, I'm seeing packet drops in Windows, and your vSphere admin will be telling you you're lying. Why? Because the vSphere admin does not see packet drops at the hypervisor. Why? Because the I/O didn't make it out of the VM. So now you have a disconnect. Use VMX.NET 3 and nothing but VMX.NET 3. Enable RSS in Windows to take advantage of this Windows scaling. And please pay attention to this KB. There was a bug in VMware tools prior to 10.1.7 where even though you have RSS enabled, we don't actually use it. So please, if you've already virtualized your Skype for Business application on vSphere and you're already using VMX.NET 3 and you've already enabled RSS, please go back and update your VMware tools to at least 10.1.7. We are at 10.1.10 right now. If you want to grab the latest one, that would be very good. Sorry, pictures? I pause. Okay. I already mentioned that the drivers for the physical NICs, for the physical devices are also very important. Please don't forget that. All right. Anybody doing iSCSI, NFS for the Skype for Business? Ingress iSCSI? Okay. All right. Please enable, where possible, jumbo frames. If you are going to be taking I/O packets over network, storage I/O over network, on 1 gig, you will get I/O latency, I/O backup. If you don't have things like jumbo frames, we recommend 10 gig, but if you don't have 10 gig in your environment, please do at least try to use jumbo frames. If you're clustering those component servers, always exclude your iSCSI NIC from Windows failover cluster. You do not want WSFC grabbing that iscosinic as something that it can use for clustering. That is going to disrupt your I/O packets. Converged network, we really don't have anything negative to say about that, except that if you don't slice it correctly, and you don't partition it correctly, it can also contribute to performance and latencies for your Skype for Business application. If everything I've mentioned to you don't seem to improve your experience with your Skype for Business, we have what I like to describe as the sledgehammer solution. In vSphere, when you create a VM, there is an option to mark that VM as latency sensitive. And because Skype generally is latency sensitive application, this is a last-ditch option that you can use if performance doesn't improve after you've done all the other things I've mentioned. It's a single point, set latency sensitivity to high, and we will go behind the scene and optimize that VM for you from the network stack all the way to the CPU. We will have exclusive access for that VM to physical cores so that they can have express lane to those cores, among other things that we do.
All right. Troubleshooting. This is always the fun part for us, right? Trying to figure out what in our environment is causing the issues. So the way I'm going to start this is anytime you have issues within Skype for Business, we got to start at the application layer, right? We're going to start and work our way back through the model and say, hey, how do I get from here? And so basically the way we do that is we have the key health indicators from Microsoft for Skype for Business. Within the key health indicators, we have 3 rings, 0, 1, and 2. Ring 0 is always at your physical layer, your components, so your servers, your network, etc. Rings 1 and 2 are all going to be application direct. They build off of each other. So if you're seeing a lot of issues at ring 1 or 2, it's because there's something at the lower ring that's causing that. So ring 0 is going to cause issues that are going to show up in ring 1. Issues in ring 1 are going to show up in ring 2, and things of that nature. So we always want to understand what's happening there. Real quickly, as we go through that, you're going to see these counters when you get to it. The one on the left, this is how it always looks. I'll just be honest. I've never seen it ever look any different, even when Microsoft runs it, because I have yet to see a completely optimal server. I'll just be really, really honest. There's always something that we can improve on, so it always looks like that. They're always suboptimal. Now, the more important one is that optimal versus suboptimal counters per ring. And again, we're going to look at that inner ring, ring 0, and we want to get that as close to 0 as possible for the issues there. Okay. The nice part about the KHIs is they give you a timeline, so we can see when those spikes happen. So I can see within the application, hey, am I having issues always at 2 a.m. in the morning? Which then I can always start to tie back to maybe I've got a backup process running, something of that nature. Or is it always happening at 9 a.m. in the morning when all my conference calls happen, right? Do I have a spike where maybe I don't have enough resources for the load, those kinds of things. So we want to utilize that timeline to understand what's happening for the ring 0. Again, I'll filter on ring 0 right away when I'm thinking that until I can solve 100% of ring 0, I pretty much don't even move on to ring 1 or 2 within that. Before we move on to the actual vSphere troubleshooting, a couple of things to note. Most of the time that we'll see within these, if you're having CPU or memory issues, they jump out. They'll come out really fast within the KHIs. What's not so obvious in the KHIs is how many times things tie back to disk I/O. And that's really important. Things like conference start time. So if you're getting complaints that it takes forever to join a conference, you start looking at disk I/O because it has to go and read that SQL database. It has to find the conference and pull it back. I see a lot of the counters that ultimately do tie to disk I/O. If you call into Microsoft, they'll actually key in on that very fast. And I know through the deployment here with VMware, we've seen a lot of that where we've been able to solve some of the issues with faster I/O. So going back to Deji's point on queues and what they've done with the PV SCSI and things of that nature, it really is important and it does make a difference for larger implementations. If you're a small shop or if you're doing a pilot and you're 10 users, probably not going to see as much there from that standpoint. But when you start talking about 100, 500,000, 30,000 users, that really does play into effect. All right. And Deji, I realized that through all of our slides, we're not going to have to go back and redo a lot of these based on the fact that all the announcements around the clients. So this week. All right, so we've got the vSphere client. We do have the GUI interface there. It is our primary tool for looking and observing performance and configuration data. The remote ESX up top, we can actually dive in and get a lot more in depth. So these two tools are going to be really vital as you troubleshoot performance to understand what's happening within it. To touch on monitoring disk performance, this one is actually, so if you start seeing some of those things in the ring 0 of the KHIs and you start tying that back to disk performance, like maybe we've got really large SQL I/O issues, things of that nature, we can actually come in and see whether or not we're having latency. I know we asked about NFS versus iSCSI. I'm sure there's some folks using fiber still, things of that nature, but this is where we're going to come in and find out, hey, is the virtual machine having issues with disk and things of that nature. So again, going back to Deji's point, get more queues. So a couple more slides here just on some troubleshooting performance, really looking at the % ready. That's typically one of the states that I look at for CPUs within the environment. And we'll touch on that here in just a second. Looking for memory swap. Are you swapping? If you are, you're probably overcommitted and that's a bad thing. And then disk read writes and the latencies components. Oh, did you have something? Yeah, go for it.
I realize that many of you in here may not be vSphere administrator. All these slides are here for you to be able to take back and have conversations with your vSphere administrators on what to be looking for when you are looking at the KHI that Adam just describes. Why are these important? These metrics are the really critical ones that you want to focus on. There are so many of them in ESX Top. You may not have access to ESX Top, but your vSphere administrators do, and you can guide them. We want to be sure, at least at the CPU stage, that ready, percentage ready, which is when the VM is, well, ready to schedule a process and is waiting for CPU time. The longer that is, or the higher it is, it's just indicating that there is CPU constraint somewhere. Now, where is that somewhere? It could be because you haven't given the VM enough CPUs, so it doesn't have enough to just put the thread and the process on, or it could be because the ESX host doesn't have enough CPUs anymore. So you will go, you ask your vSphere admin, they will look at the VM, look at the ready. If the ready is high, they will look at the host. If the ready is low on the host, then we know we have enough CPUs at the host, but we haven't given the VM enough. If ready is low, is high at the guest, and ready is also high at the host, then we know that we don't have enough physical cores on the host to satisfy the requirement from the guest. Let's go into maybe the disk one I already explained. I want to move to a more detailed explanation of what this all means. For example, co-stop. Okay, most times when you have processors within a VM And some of those processes, some of them can be hot, some of them can be in use in more demands, and some will be just lagging and not doing anything. What we try to do on vSphere is we try to normalize that situation by stepping on the runaway CPUs. Now, you might be wondering, why would we do that? We want to be able to parallelize and optimize the access to cores and CPUs on that VM. And if we see that one set or subset of CPUs are harder than the other subset, we don't have a choice but to slow down the other ones. Remember when we started off and we said more is not always better? This is that situation where you want to say, okay, do I really want to give this VM 30 CPUs or 12 CPUs when it's only needing or using 6 or 4 or whatever? When your cost stop is very high, it is time for you to reevaluate the allocation of CPUs to that VM. Please pay attention to this other one. When you ask your vSphere administrator to build you a VM for your Skype for Business workload, they bust out a template and they deploy these VMs from the template. Now, they built the template 6 months ago or 6 years ago. When they built it, they set a limit on that template to prevent abuse. So they set a memory limit of maybe 6 gig or 8 gig or whatever, and you've asked for a VM with 32 gig of RAM. Yes, they gave you a VM with 32 gig of RAM, but with the limit set at 8 or something lower. That VM will never ever be able to get 32 gig of RAM. Limit is limit and is constraining. So if you find yourself in a situation where you think this VM is rightly sized and it's not getting the resources or the performance, you're not getting the performance you need from that VM, always ask your vSphere administrator to check for limit. We surface this in ESX Top. Max MLMTD is what we call it, is the counter. If you see that going up high, there is no if or but. That VM has limit set on it, and it doesn't matter if you add 1 petabyte of memory to that VM, it will never get access to that. We do not do memory reclamation. We do not swap. We do not balloon. We do not do any of this unless you have contention in your ESS cluster. If resources are not contended, nobody is swapping anything. Nobody is ballooning anything. There is no reason for you to disable the balloon driver in the first place. Even if you are contending, remember I mentioned earlier, if you reserve the resource for that VM will never give anything back. These are the counters you want to be watching for in ESX Top if your VM is constrained. So you?
Yeah. So I was going to say, do you want to?
Yeah, let's do the packet one.
Okay, go for it.
Okay. If you have RSS enabled, when you look in Windows, your drop packet should be minimal. Drop packets are a thing in networking, in all IT infrastructure, in any server, in any OS. They shouldn't be systematically increasing. If they are high, and you see in ESX Top or in vSphere or inside Guest that this is happening to you, please check RSS first before you take the option that VMX-Net3 is the one causing the issue for you. I'm very sorry. Okay. We have links to best practices, and we have, I believe you're getting this recording. We are going to make time available for you to ask questions because we know we just dropped a lot of things, a lot of information on you. So we are going to, at this point,
Open it up for questions.
Open up for questions. And we would like to thank you also for being very gracious with your time with us. So I get paid, by the way, by the number of questions I get at sessions. So please make it worth my while.
You get paid?
Questions? Has this been a valuable use of your time? Okay.
Awesome.
All right.
Yeah,
Okay.
that's good.
All right. Awesome. Awesome. Okay. Thank you very much.
Yeah,
Thank you for
appreciate it,
being
folks.
gracious. Thank you for being here. We appreciate the time.